James Tagg has been a speaker at many ClueCons, so as you can see, he's very practiced at getting set up here. James, how many ClueCons have you been to? He's been to 8 or 9. He's been a long-time ClueCon attendee. You're good to go? Oh, hold on. I'm checking. You're good? You got your screen up? Okay, mic's not on. Sir, check your mic.
Hello.
There we go. All right.
Right, I'm going to break the rules and do lots of video. So
lots of video. Do you need audio on your computer, or?
No, I don't think I've got anything that requires audio at the moment.
All right. Well, then please, we have on our stage with us James Tagg. He's the CEO at Sen Inc. He is one of the inventors of the touchscreen. He founded TruePhone, the first global mobile network. He holds a ton of patents. He wrote the book, Are the Androids Dreaming? He's going to give us a discussion of the challenges in rendering realistic artificial humans. The title of his talk is Communicating with AI Avatars. Give a big, warm ClueCon welcome to James Tagg.
Okay, so I'm going to show you where we've got to and sort of where we're going and some of the mistakes that we've made so far in this. So let me just sort of describe what Sen is doing. Sen is trying to make digital human beings. And if you've read my book, and if you haven't read my book, obviously go to Amazon and buy it, you'll know that I don't believe that we'll ever actually make a complete digital human being. I think humans are different to artificial intelligences, but we're going to have a good go. And the unique thing about the way that we do this is that we bring humans into the loop. So this is our current alpha. So this is basically a chatbot, let's face it. So we have a WebGL character here, which is lip-synced and so on to the text. I can type in a question, I can get an answer back, and then what's actually happening is that there's a Minder interface. Do we get the Minder interface? That pops up, and a human being can intervene and answer the questions correctly if the AI is going to get it wrong. And what do we do with this? Well, we basically do sales off the website, off people's websites. So we will describe a product and explain what's going on, ask the customer questions, give them answers, take their details, and so on. So it's a matter of trying to kind of build empathy with the customer from a digital avatar. So we've had some problems with our current system. So our current system is quite complicated, but it's also quite basic. So we have sort of 4 things that we have to fix. So the first one is the AI is very basic. It's AML2, and if you know what that is, it's basically a kind of string in, string out system. So it's not a huge difference between the original Eliza Doctor. So I don't know if you've all played with Eliza Doctor, and sort of you go to this very, very simple program and you go, I am not feeling happy today. And the Eliza Doctor goes back and say, tell me about you're not feeling happy today. And it's a very, very simple string substitution. You can imagine you can take string substitution, to a whole extra level if you really want to do it. But it's still basically string substitution. The second thing, of course, is the graphics are low poly WebGL, fairly basic, not terribly attractive. You're not going to develop empathy with our current WebGL avatar. The minding that we have, where we actually have humans intervene, is only really working in the text channel. So we're not listening to the voice, and we certainly don't have anything on the video side. And then the other fun and games thing, of course, that happened in the last year is that we had the ICO winter. So basically raising money through ICOs and sort of public offerings through that route became very difficult. So we did do it, and we closed ours in April, but we didn't raise the $1 million we wanted to raise. We raised about 150,000. But we did it, in the ICO winter. So What we are doing now, though, is we're moving to sort of hyper-realistic. So this is our, it doesn't have audio, so you're not missing audio, it just has a soundtrack. But what this is our application for an Unreal grant. So Unreal are giving out money to use their gaming engine, and we're going to use their gaming engine for driving the avatars. So the problem at the moment that we have is that AIs are fairly simple, they get things wrong. We put humans into the loop in order to fix those things. And here's a minder. The human can intervene as the questions come in real time and fix it up. And then as those questions are answered and fixed in real time, we can update the AI database in the back. And then we actually have a bank of people in India who act as those humans to intervene. So we have a big communications task in getting all of the communications, all of the streams, out to India and back fast enough to intervene. But we also need to do that for voice and video. So we're actually tracking video for the customer and seeing whether they're responding correctly, and then moving to hyper-realistic avatars. So there's a very interesting thing in communications, of course, at the moment, which is these avatars are becoming important for communications compression. So one part of it is compression, so it's a new type of codec, effectively, and the other part is because of virtual reality. So if you want to send an image of someone's face somewhere, you can use WebGL, compress it with VP8, and send it there. Or you can make a model, a 3D model of their face, and send the 3D model of their face, and then only send the instructions as to whether the person is going to yawn or smile or raise their eyebrows. So you can imagine that the quantity of data that you're sending to just manipulate someone's face in real time is way lower than the pixel stream. The other reason this is being used is if you have a virtual reality headset on and you're talking to someone else with a virtual reality headset on, you don't have a face. You have a headset on. So what happens is that, so this is a demonstration of Facebook's system, and they have sensors, pressure sensors in the AI, in the virtual reality headset, and then the cameras that are inside the headset can see the eye, and the cameras on the outside can see the rest of the face. And using all of that, they can put back together a human face that's talking and project the avatar as if you're talking to the real human being. So you have the advantage of compression, and also the person you're speaking to has a face rather than these sort of goggles on. But there's a problem with this sort of WebGL approach to things. So if you see, the state of the art now is probably Siren, and this is what you can do in terms of a hyper-realistic rendered human being, right? So full motion capture, face. I'll go into a little bit more detail how it's done, but you would find it difficult, unless you're an expert, you might find it difficult to actually tell the difference between the real person and the human. And then a lot of the time, the tests now are done are a short clip of the person and a short clip of the AI, and see whether you can actually really see the difference. And it's getting quite hard to see the difference. But WebGL, when you WebGL things, you end up in a low poly situation. So here's Micah in high poly, and you can see again, this is Magic Leap's avatar. Very, very good, high precision, photorealistic. The hair's not quite as good as Micah's because it's not modeled in the same way. But as soon as you move to the actual version that's going to release, you can see that it's become much more cartoony. So there's a low poly version and it doesn't necessarily look like a human being anymore. You haven't crossed the uncanny valley. Now, of course, this is an incredibly impressive demonstration because this is mixed reality. So some of the things in this picture that you see are not there, and some of them are. She is not there, right? She is in your virtual reality headset, but this room is real. Some of the objects in that room are real, the table, for example, and so on. So that's mixed reality. But you can see you kind of lose, you really lose what you wanted. And if you, well, and then if you really sort of see what things end up looking like on the web, here's an example. And you can see it's good, right? But it doesn't look natural anymore, right? The movement of the mouth and the jaw is very sort of translation, right? It's not a real, you don't have the photorealistic effect of the face, and the sort of the static thing is just I sit here and I blink occasionally, which obviously maybe some of us do in real life anyway, but it's not super engaging. So what we want is an architecture that allows us to get that hyper-realistic effect on your laptop. So what does a hyper-realistic avatar involve to actually build it? It's sort of, well, it's quite a long pipeline of stages. I'm going to have a go at a dangerous demo in a few hours' time where I'm going to try and go through the stages between now and then do the last stage up on stage and see if I can build James in 3D as an avatar. I have been scanning him already over the last last couple of days. So what you do is you take a person and you photograph them in a light stage. And the important thing about the human face is that we look different depending on where the light comes from, because we have subsurface scatter. So if light comes into your face at an angle, it will reflect out from the deep tissue layers, and you'll get a sort of particular look. So if you have light coming straight on compared with light coming in from the side, you get a different look. So in a light stage, what you do is you do a fax capture. So basically, you'll sit in a light stage, you'll do a neutral face with lights from 200 different directions, and then you'll do, I'm scared, I'm worried, I'm wondering what's going on, and so on. So you'll do all of these different expressions, all captured from 200 different lighting locations and cameras, so you get this massive data set of the person, and then you construct it into 3D. So that gives you kind of a static system plus the motions, and then you go through, and then this is an example of Jackie Chan. So this is how good you can get. Why is that not rendering? This is how good you can get a sort of a static capture. But then what you also have to do is you also have to do the motion capture. So the motion capture is now so good that you can do it in real time. So what you can do is to plug a motion capture facial animation rig and a motion capture suit into LiveLink, which is a technology from a number of different companies, but mainly Maya, which is Autodesk, and Unreal, right? So you can do this, and you can animate the character in real time. So you've got the ability to animate this captured character in real time. So what's going on here is a massive amount of processing in the background, because you remember we took 200 lighted photographs of every different expression of the actor. And in real time, in the Unreal game engine, we're putting that together. So depending on the lighting that's incident and the direction in which the motion capture is going, we reconstruct the face in real time from all those underlying scans and the textures. And so we make an actor in real time. So that's Now, this, of course, is not terribly scalable, right? The motion capture suite set up there is probably $100,000. The software is $10,000 per seat license. The translation between single actress and single avatar is a $10,000 AI solve to match every motion of the face to every motion of the avatar. So this is quite a big thing. But it shows you that you can get a really, really good result if you want. So here's the architecture that we're implementing. So this is basically Unreal Engine with real-time motion capture in, builds the face and human in real time, and then in order to get the quality output, we then pixel stream out of Unreal, which is a native feature of the engine now, into a WebRTC proxy, and then from that WebRTC proxy we go out to the customer's browser. So we can get a hyper-realistic, you shouldn't be able to tell the difference between a human and the AI all the way from a server farm out to someone somewhere in the world. Now, just to make it even more fun, we actually want to be able to change the animation in real time. So the group of people in India can use a cheaper system. This is not the full body motion capture. This is just a face capture. But you can see that Will, my able assistant, is talking. The camera is picking him up. And the camera is running this face, so this face is mimicking him. So you can have someone answer a question in India that's come in. They can answer it. We can motion capture in real time as they answer the question, and then store that in the database. So we've got the ability now to intervene in both the audio video stream and the text stream, and cache responses in a server, and render stuff at very high resolution. Let me see if I can just get that. Okay. Some other cool things, pieces of technology that are quite useful. Where do I get my actors from? Well, you can all audition in the bar later, but basically, you spend your time looking for people who have great facial expressions. There's just something about the way they work. But also you have some difficulties. You don't necessarily want to have someone who is a distinguishable human being, because what happens if you scan a Republican and you want them to you want to sell the image and the technology to the Democratic website or some equivalent sort of thing. You might have restrictions on what a person is prepared to say who is a recognizable human being. Because remember, we've now scanned the person so well that you can't tell the difference in many instances between them and their double, right? It's a complete double. So one of the things that an NVIDIA project did is allow you to take a bunch of these scans and then invent a person that's partway between scans. So you can make an imaginary person that's not actually a distinguishable human being. They're sort of a mixture. And then there's another project, and of course you want to do this for every culture. So there's another project, university project, where they synthesize faces out of lots and lots of different examples of people to get the average face for a particular country or society. So you need an average invented male and female person for each country to be your AI avatar that you can deploy onto a website. So that's what we're doing. So that gets you a face and a voice. I didn't actually explain the voice as well. You can now do wave synthesis using AI. You scan in about 2 hours of example text from someone, and then you can synthesize that voice. And you can synthesize the voice very effectively. So effectively that you can convince their bank manager that they're them and steal their money. So there's all sorts of ethical considerations that if you can actually make a double of a person, how do you secure it to make sure it's not misused? Then, of course, you've got the intelligence part of it. So we were using AIML, which is an OK AI system. I know a number of you have used Dialogflow and Luis and the Alexa authoring system. So those are really second generation systems in that you can give example text to them and say, what do you think this person is saying? But the conversational AI is a state machine. So you'll go through and say, I want a flight from A to B, and if the AI misunderstands the B, then you have to have a conversation about misunderstanding where they're going to and fix that up. So we've now moved to a system called Rasa, which is an open source AI system that both applies AI to the natural language system and also the conversational dialogue. The nice thing about Rasa is it's open, and if a new piece of research comes out, then you can plug it in within a few weeks and have it up and running. So we're now using the unsupervised learning Facebook research that came out a few months ago in the AI system. And the nice thing about that is so a lot of these AI systems, what you do is you give them the entire Wikipedia, you go away for a week and you come back and they've trained a TensorFlow model on Wikipedia. That means that the model knows subject, verb, object. It knows trees are a type of item. It knows trees are similar to flowers and plant. It has these sorts of links to it. The problem is if it's not in Wikipedia, it has absolutely no clue what you're talking about, right? So if you're talking about SIP, there's not much SIP in Wikipedia, so it won't cope, or anything medical or whatever. Second thing, of course, is the models are enormous. Right? You end up with 8 gig models. Now, if you want to put that on a mobile phone, you're in difficulty, and they're only one language. Generally, you'll train it on a particular language. So the nice thing about the unsupervised learning is you give it all the text that you're going to train it on, and you train it on your data set. And then the dialogue system is quite cute. What you do is rather than build a state machine, you build a set of happy and sad paths. And then when you press to compile it and it builds another TensorFlow model, what it does is it stitches all of the dialogues you've put together, it randomizes them, stitches them together, and makes much bigger dialogues. And then it runs an AI algorithm that says, given the history of the conversation to date, what's the most likely dialogue to be the right one to go to next? So it takes a sort of fuzzy logic approach. So rather than having to keep track of this extremely complicated state machine, you put all your stuff into a TensorFlow model, and you do it. And then the other nice thing about it is you can actually talk to it in real time in an interface, and then if it's got it wrong, you can just go in and say, no, you got it wrong, do it again, and then that will update the model data, and then you can retrain the model. So you can keep your model being retrained all the time and sort of dynamically improve the system using call center agents or whatever, rather than extremely expensive AI programmers building AI from scratch all the time. So that's the AI subsystem. And then, of course, the final thing is, so that would be like a generation 3 natural language system. So it's using AI in all of the processes, but it's still quite stringy, right? You're still saying, I would like to take a plane from A to B, and then it's replying with a pre-canned string. So what we're moving towards is knowledge graph systems, where there's a database, a graph database, that understands that bank balances have, well, bank accounts have balances and so on. So you'll ask things like, what is the property of this thing? And it will answer, the property of this thing is X. So you've abstracted away what you're talking about from the sort of the way you talk about things. You can separate that. So you can build a big graph knowledge base, and then the language will come out of that. And that's believed to be somewhat of the way that humans think at certain times. Now, the problem with humans is we flip from one bit of AI. If we are AI beings, we flip from one bit of AI quite casually to the next. So 1 minute will be answering a question in a very logical way. The next one will be programming, which is a particular type of skill. The next thing will be doing sort of executive action stuff, like, so did I book my flight, to get from here back home? I need to go and do something. So we have lots and lots of things going on. So, I mean, really, this is only doing, sort of natural language question and answer type discussions, but in a fairly general way. I don't think it'll pass the Turing test, but it'll give you a kind of a decent conversation. And then the final bit, of course, is that blockchain seems to be somewhat back. I don't know whether we're going to go back and sort of resuscitate all our blockchain work, but Bitcoin has sort of recovered, and the SEC approved a utility token. In fact, it's a polymorphic token. It's the block stack token. So that's a token which you can buy as an investor, you can make money on it, you can sell it as an investor. You'll have to sell it through a broker dealer, through the normal system, or you can earn those tokens within the token economy and cash those tokens in within the token economy, and it's a utility token. So it actually keeps track of how the person came to buy the token and how the person is selling the token, and try and put a cut line in between. No, you're an investor, so you need to be treated as an investor. You're a utilitarian, so you need to be treated as a utilitarian. So that's it. That's what we've been doing across the broad spectrum of building a digital human being.
All right, big round of applause for James Tagg.